And there we go. So today we're going to talk about troubleshooting, and we're going to talk a little bit more about slicing. And the troubleshooting, as it turns out, I think was a good choice because we've been having some problems doing stuff. So, this is all about the practical aspects. We're going to learn about practical use of your 3D printer to replicate downloaded objects and about using Kira for slicing. Here I've got a couple of pictures of failed 3D prints, and we're going to talk about some of the ways that 3D prints can fail and why, more importantly, and what are the things that you can do to help prevent that. Okay, this is one that you can see it's kind of drooping and running all over the place, and it ran out of filament. This one, the little boat thing here on the right, this is something called Benchy, and it's a test object. You can look for Benchy, and there's all kinds of versions of Benchy out there, but it's a little boat, a little tugboat basically with a face. And it kind of, if you have all your settings right, you should be able to print it, and it should come out looking like a little toy. And if not, it would look pretty horrendous. So it's kind of a test for whether you've got your 3D printing settings all right. So when 3D prints go wrong, so, finding objects to print, customizing them, designing them, it can be a lot of fun and it can be very rewarding. But when things do not go the way that you expect, it can be very frustrating. We would really like to eliminate the frustration factor and help you just to be able to get to the fun and rewarding part, right? That's really important. If you have the right printer and the right filament, and if you follow a few simple precautions, we would like to be able to help you avoid much of the hassle. So we're going to look at some common problems and their solutions. I've included a couple of links here. One is simplify3d.com. They have a really nice print quality troubleshooting. Let me just show you what that looks like. And here we go. I'm going to start that up. Okay, here you go. All right, so now you see this print quality troubleshooting guide on simplify3d.com. Now, these folks they want to sell you their own slicing software, which costs 150 bucks. And I know you're thinking, wait a minute, I just paid not much more than that to buy a whole 3D printer. No way. And I would agree with you there because I think Kira is really awesome. It's great. But it's a great guide. It's a visual guide. So like you can see here what it looks like in a kind of a glance with different problems. Some of these are really big problems, like you can't get the thing printed when you have this problem. Not sticking to the bed is one of the big problems. That's usually because your bed's not leveled. Layers separating and splitting, grinding filament. Here you can see what happens when there's a little thing a little gear that kind of grinds the filament, that pushes the filament into that tube that goes to your hot print head, right? And if things get a little stuck or a little jammed, or maybe if you have the temperature too low, the gear might start to bite into it somewhat. And once it starts doing that, it'll just keep grinding away at it, and you get a little dent in it, and it won't go anywhere. It won't move forward. Or you could have a clogged extruder. It's a pretty good guide that covers all kinds of things that you may not see happen. This warping one, this is very common with ABS. It also might happen if you don't have your print bed leveled, and then things are not sticking to the print bed. Okay, so this is one. Let's go to another one here as well, which is this. Whoops. Trying to open links from my slideshow is just proving to be a little. Here we go. All right, so you should see this now. This is the all3dp.com, which is kind of a nice site. It's a nice blog. They are really heavy on the advertising. You just see lots and lots of ads, but they actually have good content. And this is a nice guide. You know, okay, running out of filament is one. Surprisingly, you can just run out of filament and then, well, I'm not printing stuff. That's because there's no filament. Nozzle too close to the bed is another one. And here's a nice picture. Here's the nozzle right on the bed. So when we talk about leveling, you know, the nozzle's not supposed to be right on the bed. It's supposed to be the thickness of a sheet of paper. And how do you do that? You have a sheet of paper and you can slide it under the nozzle and you should feel it drag on the nozzle, but you shouldn't have it tearing the paper because you have to pull so hard. Okay, so that's it. When the nozzle's too close, the melted plastic can't come out if the nozzle is blocked. That's another problem. That should hopefully never happen to you unless you end up using cheap filament. And we're going to talk later about how bad cheap filament can really be. And anyway, this is a, you know, it's a pretty good guide. So I've got the link in there. I'll put these in the, this is in the slideshow, which is going to be on the forum as well. So let's get back to our slideshow. Okay, so here we go. I chose a couple of pictures here. This one up at the top right, this is one that's warped, and you can see it's lifting from the bed, and it's and this is one where, you know, it kind of just went to pieces. Sometimes we call it spaghetti, or we call it a rat's nest. And sometimes you can have the, you know, you can have just a filament piled up all over the place. I think I have a picture in one of the later slides like that. So what are some of these? Are some problems that are specific to FDM. FDM, remember, is fused deposition modeling. And you know, what we said, we're not going to worry too much about FDM versus SLS versus all the other acronyms that we have in 3D printing. Well, this is a case where it's important because FDM has its own things. Now remember, the principle with FDM is you have a print head that lays down melted plastic on the print bed in a pattern, and then it goes up a tiny bit and it lays another layer on top of that, and it just keeps building things up layer after layer. And the first layer is very important. It has to stick to the print bed. If you follow the best practices that we recommend here, you should mostly be able to avoid a lot of this. But it's good to know what to do when things aren't going well. Now, I can't emphasize enough, you have a way to get help. If you can post something on the forum, I check every day and I can help you and give you, you know, specific input. Just sometimes I need to know more about what the problem is, okay? Some of the most common issues that will cause your print to completely fail would be the filament not feeding, having the wrong extruder temperature, or the first layer not sticking. And the first layer not sticking to the print bed can be caused by not having the print bed level. There are lots of other issues that could result in prints that are complete, but they have visible defects. These could be caused by problems with flow from the nozzle, incorrect extruder temperature, poor filament quality. That has been my only problem with the Ender 3 Pro is I got one roll of bad filament, and that has caused me a lot of pain. Defective models, I've tried to print one or two that had problems, and I had to figure that out. And then there's some other issues as well. So what are the best practices? Okay, let's start with some things that you should try to adopt. Number one, try to not use bad filament. And you can then ask for advice if you're not sure why a print has failed. It's not necessarily because of bad filament, but it could be that you're doing everything else right and you have bad filament. How do you know you have bad filament? A sure sign is if it snaps easily. So I should be able to, it shouldn't be like a piece of uncooked pasta. You know how if you try to bend a piece of spaghetti, it'll just snap? Filament should not ever do that. No, 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 no. On the other hand, it's not going to be like a limp noodle, but it's going to be, plasticky and bendy. And just bending it a little bit should definitely not make it snap. If it snaps, that's bad filament. Don't even bother with it. If it's brittle, it's not going to print. It's going to snap off, and that's going to cause you a lot of trouble. If you have more than one spool of filament, try to keep your unused spools in their resealable bags with the desiccant packet. I have a picture of that later. Excess humidity can degrade filament quality over time. Now remember, we said there were different materials that you can use in 3D printing, right? And PLA is the one that we would recommend that you stick with. It's really easy to work with, but it's sensitive to humidity. So if you leave it in humidity, it will tend sometimes to swell up a little bit. So PLA is great because it's a naturally non-toxic natural material. It's derived from cornstarch, tapioca starch, potato starch, different starchy natural materials. But it also will tend to absorb moisture, and that can make it swell up. Okay. Make sure your print bed is level. When you start out, the first thing you need to do is make sure your print bed is level. Okay. If you have a print job that has problems, or if it comes too easily off the build plate, or if it moves during printing. Where's my chat window? Let's see. If it moves during printing, that's a sign that you don't have enough adhesion on your build. Okay. Let's see what happened to my. Sometimes Zoom does this thing. Here we go. Yes, so there we go. There's Daniel. Hi, Daniel. Yeah, so Daniel is pointing out that snap test is one way, and look at reviews is another thing. So if you're going to buy things on Amazon, then you look at the reviews definitely, and people will leave. If I get bad filament, I will leave a stinker review on something, and if you see a lot of stinker reviews, you'll see a few always, because there's somebody who just was having trouble with the printer. But once you know some brands that work for you, you can usually stick with those, and that's usually a safe thing. Another safe rule of thumb: don't buy the cheapest one. Okay, if most of the filaments are $22 for a 1 kilo roll, or $24, and some of the better ones are $28 or even $30, that's okay. But then if you see the one that's $18, that might be a red flag to not get that. That's in fact the only roll that I had trouble with. I wanted to get red filament, and there wasn't any better red filament, so I took a chance on this one and I lost. That was a horrible roll of filament. Now Taylor has a question, so let me address that. What happens when the filament won't go through the tip? All right, so when you load the filament in the printer, your print head has to be hot. If your print head is not hot, it won't go all the way through. So once it goes through the pipe, it should go all the way, and then you should be able to push it. And as you push it, it gets to the print head and melts, and you should see stuff coming out, okay? If that's not happening, it means either you don't have the print head hot. You can see, if you look down there at the little LCD, it'll tell you whether the print head is hot or not. Or it could mean that your print head is clogged. The print head can get clogged if you leave it hot for a long period of time without having filament go through it. So if you ever have a problem with your filament not feeding through, you need to cancel your print job and make sure you turn it off. How do you unclog a print head? Okay, so there are a lot of videos on unclogging your print head. And basically, it depends on how badly it's clogged. There's a little piece of piano wire that comes with the Ender 3, and it will fit through the 0.4 millimeter tip of the nozzle. It's a little tricky, and it's also just a little dangerous because that wire is really sharp. It has a sharp tip, and you have to do that with the nozzle hot. That can sometimes let you unclog it. The other thing is the Ender 3 Pro comes with a set of wrenches, and the print head has a little silicone boot on it. So you turn it off and let it cool, right? And then the silicone boot comes off, and one of the wrenches can be used to gently unscrew that brass nozzle. And then you can clean out the brass nozzle carefully using needle nose pliers or tweezers. Hopefully you can get it unclogged that way, and then screw it back on and put that. There are a few different methods. Keep in mind that the nozzle should be machined on the inside, so it's very smooth. It has kind of like a little funnel that goes smoothly down, so when the filament is pushed in, it will flow out. And if you scar it by using a harsh tool like a drill bit or something, even though that may be somewhat tempting, you could damage the nozzle. The good news is replacement brass nozzles are fairly cheaply available, and sometimes it's just easier to replace the brass nozzle. And the chamber where everything melts above the nozzle is usually not going to get clogged. It's almost always going to be in the nozzle. That's a choke point. It's all funneling down to a little tiny 0.4 millimeter thing. Okay, so you can get those on Amazon. You can probably pay 10 bucks and get about a dozen of them. Now, okay, so here's another question. All right. If you can get your print to stick to the bed when you use painter's tape, but you can't get anything to stick directly, is that okay? Now, I'm assuming you are using a glass print bed. Okay, is that right? Are you using glass? If you're using glass, then there's two things. One, make sure that you use the paper test to get the print bed level. You've got to have your sheet of paper. This is that tool, a sheet of paper, and you should, have the print bed so that it kind of gives some resistance moving the paper like that, right? And that's one thing. Number two, I always use hairspray. So there's a Garnier Fructis number 5. Yeah, Daniel uses Aquanet. I use the Garnier Fructis number 5 that's made from bamboo. And you give a light spray of it when the print bed is warm, and that will help it to stick. I've never used the painter's tape on glass. And I don't even have to spray that every time, the hairspray. I'll spray it maybe every 8 print jobs. I think that is it a smooth print bed Is it really smooth and hard? I'll have to check on that because you're using the MakerBot, and I thought the MakerBot is like the Ultimaker, which uses glass, but I'll have to check on that and I'll get back to you. Okay, so a few more things. Yeah, I can look it up. I'll look up the specs on it. Um, and and use the right temperature. Sometimes you need to use the right temperature. So I've often found that sometimes all black filament has things added and it needs a bit more of a kick to melt, sometimes 5 degrees Celsius or 10 degrees Celsius higher. Once you find a good set of slicer settings, you should stick with that and just change what you have to. Make sure that the model you're trying to print is designed for FDM printing, and you can look at other people's comments on Yagi or Yagi or Thingiverse or whatever. You want to always watch the printer for at least part of the first layer. If you have problems sticking to the bed or not extruding filament, these will almost always show up right away. It should only be about 3 to 4 minutes from the time you send a print job until it starts putting down the first layer. So if you just watch it in the beginning, you should see the first layer should look really, really neat. It should have clean edges, it should be really neat, and there should never be a strand of filament that is kind of floating on the print bed. It should be stuck down like it's neatly painted on in a precise pattern where they all fit together. You shouldn't have gaps, okay? And then once you've got the print job started, check in on the printer occasionally. Make sure the filament's moving in and the print head is at the level of the top of the model. You could run out of filament and then you might have it printing and see that it's moving back and forth, but then you look at the print head and you'll see, oh, it's this high above the top of the model. I haven't been printing. It's been running for the last hour. And as Daniel said, reaching out to other people is a great way to get help. Okay, so you can join a Facebook group, or you know, and even on our forum, I've been watching that, and you know, there are lots of people out there who are willing to help. And you know, there are often things specific to your specific printer. Okay. So these are just some best practices and some good things to do. All right, so what is so bad about bad filament? Okay, that's the question. What's so bad about bad filament? I keep saying bad filament is bad. Bad filament is bad. Don't use bad filament. Why not? What's wrong with bad filament? Well, here's a picture of my original PTFE tube. PTFE, by the way, is basically Teflon material. It's a non-stick material, right? It's supposed to not stick. It's supposed to have your filament go smoothly through it. Do you see the red stuff inside? Well, that's my cheap filament that got stuck. Now, I'm a cheap person. I'm very cheap-minded. I recycle everything. I reuse stuff. If we're throwing out a piece of furniture, I'll break it up and I'll keep the pieces of scrap wood in the garage in case I want to use it for a project. I am very cheap and I'm very hard-headed. So I said, look, I am not going to give up on this bad filament. I replaced the PTFE tube. I got to buy a replacement on Amazon. And I thought, I'm going to try to get my money's worth. I've got like 0.6 kilos of this cheap filament. In the process, I got some things printed, but I managed to clog another PTFE tube, which is not shown here. So just don't buy cheap filament. Read the reviews. If you don't have reviews, get another color. And I certainly did leave a real stinker of a review for this one. Oh, I also should mention, I also did replace my print head as well as a result of using this cheap filament. I got a clogged print head. And let's see what's happening right now. Video seems to have stopped, so I'm not sure if everyone can hear me. All right, what's happening here? Can everyone hear me? We seem to be maybe having a network problem or something. Okay, you can hear me, great. So let's move on to the next slide. Keep your filament fresh. Okay, so remember so this is what good filament packaging looks like. It came in this vacuum sealed 2-gallon heavy duty resealable Ziploc bag. You can see the Ziploc thing up at the top. And there was this little packet of desiccant. If you look down here, right at the, right here at the bottom, you can see this little packet of please do not eat this desiccant. And that's to help keep it dry because it doesn't like the humidity, doesn't like moisture. And when you're not using a spool of filament, put it in one of these bags and seal it up. And this will help it to stay unbrittle longer. Okay, so that's a good thing to do. The other thing, keep the print bed level. It's not hard to do. You know, you need a piece of paper and you use those little thumb wheels, and you should only have to do it maybe every 10 prints, or maybe more often if you see that your prints are starting to go a bit crazy and things are not working. Here's a print I had done. I was printing a really large thing, and you can see the first layer just didn't come out right. You can see where it's uneven in places, and the filament actually stopped feeding. This was good filament. It was a very good filament that I was using, and I believe it was just a problem with bed leveling. So you've got these really large thumb wheels, and they're used to raise and lower the print bed one corner at a time. If you change the print bed surface, you might have to lower everything all the way down and then re-level. And for example, instead of the magnetic removable bumpy surface, you might switch to glass. Leveling always starts with homing the z-axis. So if you look on the left side of your printer, which is not in this picture, there's a little tiny switch on the left. It's a little roller switch, and it clicks when the print head is just above the print bed. The print head, which is the little brass part that sticks out, should not actually touch the print head. Yeah, it should not actually touch the print bed. You should be able to slide a piece of paper between the print head and the print bed, and it should drag just a little bit. And there are videos and links on the forum for print bed leveling. The springs on the Ender 3 Pro print bed are sometimes a little weak, and sometimes if you're trying to level it, it seems like the wheel moves too loosely. You might have to raise and lower it a little bit until it engages. So you have to do it a few times until every of the 4 corners is all going very. I'm going to try restarting my video. Give me just a second here. Here we go. And my video is not starting. All right, well, we don't really need the video here. When you put things on YouTube, sometimes if it's just a slideshow without the video, they will sometimes reject it. So I try to get the video in there. Anyway, so the z-axis always will take it down to the same place. And if the leveling wheels are not working, you sometimes have to just raise and lower it a little bit. But you have to get the leveling right, and it has to be leveled in all 4 corners and then also in the center. Okay, you might eventually want to replace or upgrade your print bed. So if you, after printing through about 6 kilos of filament, the print bed that came with my Ender 3 Pro was starting to look like the picture it right. This is the actual print bed cover. It got smooth, and it had some places right in the middle. You can almost see where it was sagging, and it was starting to be a real mess. But I did a lot of printing to get to this point. I mean, probably as much printing as you might do in 2 years if you're, a normal, sane human being. Anyway, I also, when I first started using it, I was sometimes in a little bit of a hurry and I would be too quick to take things off, and I caused a small amount of damage. I could get a drop-in replacement on Amazon. It was 12 bucks. So that was a fairly painless thing. Ultimately, I've switched over to glass, which you see in the bottom picture. It also gives me the option of printing with things that need higher temperatures like ABS. To print with ABS, you need to make other changes, but they're not too hard. The printing on glass does work with the right settings. Here you can see I did a replacement sewing machine spindle. It's about, oh, that big. It's about maybe 8 inches long. And it printed all upright, the whole thing, and it was just on glass with hairspray and no brim. That's the Garnier Fructis Level 5 bamboo-based hairspray. But you know, you can find whatever works for you. It's just a very light coating, and maybe every 10 prints or so. Okay, so that's you know, changing your surface, but you need to get off the ground first. So more failed print examples. Here are some from my printer. This was the fidget star. I had originally recommended this and said that would be a good first thing to print. Well, that wasn't really a good recommendation. It was a pretty lousy recommendation, in fact. I'm trying to get back to the chat window. Here we go. So this is the fidget star, and it turned into spaghetti because what was happening. Remember FDM, you start by building up one layer at a time. Every layer needs to stick to the layer below. It's very precise and it has to stick. If it doesn't, this is what happens. So the fidget star was a nice idea, print in place with hinges, but then it started to weave. It started moving with the print bed. That should not happen. Your thing should be totally stuck to the print bed, and it should completely move with the print bed back and forth, and then you've got your print head goes back and forth X and Y in the X direction, and lays down filament. So I ended up with spaghetti, and that failed. The middle, this was a battery dispenser, bad filament. You can see I pulled out the tube there. I had to pull out that little thing so I could take this tube out. And then I ended up replacing the tube. This was the tube I showed the picture of earlier. I had to replace the tube. The filament snapped, and I didn't notice this until an hour or so had passed. So this was long enough for the filament to get baked into the end of the PTFE tube. I had to replace the PTFE tube and the print nozzle. So let me explain this a little bit, okay? PLA is nice stuff, but it's a little sticky. And think about, let's say you're baking cookies, right? And you spill some batter in the bottom of the oven. That's going to get baked on. It's going to become hard. It's going to get, you know, plasticky. The sugar is going to melt and caramelize, and it's going to be messy, right? That's pretty much what happens if you keep the print head hot for a long period of time and you don't have filament moving through it. So that's one of the reasons why a print head can clog. And that was exactly what happened here. The bottom here, the print bed wasn't level, and the first layer did not extrude evenly. It was too thin and too ragged. And then I had to cancel the print job because the print bed wasn't level. After a failed print job, you might have some globs of plastic hanging off the tip of the nozzle. So here's a little close-up picture. You can see this little picture here at the bottom. And this part here, this is the nozzle, that little tiny brass nozzle. This black thing is the silicone shroud around the print head. and it pops right off, and then you can unscrew. There's a hex thing you can use with a wrench to get the print head out, to change the print head. It's actually pretty easy. But this is what the bottom of the nozzle looks like. And you have to make sure there's no plastic. There's not even a little tiny glob of plastic, because you have to be literally the thickness of a sheet of paper off the print head for this to work, okay? All right, so that's a little bit about troubleshooting. Again, there's a lot more to it, and there are specifics on different specific problems that you might have. But I also wanted to talk about slicing with supports, because we're really almost out of time here. This is a very useful accessory. It's on Thingiverse, and it holds all the tools. You can see here a picture. I've got all my tools. I've got the scraper, the flush cutters are hanging off a thing there, all the little wrenches and hex keys, they all fit securely in this. And there's even room for my long tweezers. The problem is that the designer did not forget to flip this over. The flat part is not meant to be down on the print bed. It's the small part that has to go down, and it needs supports. So this is something you have to use supports. This is what it looked like when it was printed. It's a little blurry. You see all that stuff down here, that solid stuff, that is support material. I could easily remove it with my fingers, but you have to get the settings right. And you might sometimes need to use pliers. There's a little problem in Cura. The default settings for support make it too dense, and it sticks too closely, and it can be really hard to remove. When you get your support settings adjusted right, they come away very easily, and especially if it's a model like this that has a lot of straight edges. So what are good support settings for Cura? So I'm using an example. This is a little extruder knob I like. It's a little Groot knob. And it's not really going to stand up to the flattened metal shaft of the extruder gear, but it makes the motion very visible. So I think Groot is cool. But this knob has to print mushroom style. The stem is pointing down, and he's got his hands dangling over the print head, you can see here. And his left hand is also hanging over part of the top of the knob. So we're going to actually have to use we'd normally use the touching build plate setting for supports, which we'll show you in the next slide how to get there. But we actually are going to use everywhere, because we also need supports between the top of the knob and his hand. So we're going to modify print settings. The first thing is we have to turn on expert mode. If you click on the drop down for Cura settings, and then you click on this little menu thing here, you get to select expert mode, and that's going to show you all the possible print settings, but there's only a few we're going to change. So you're going to, under support, go down and find support, and you're going to check generate support, which then opens up a whole other set of things. You want to change the support to everywhere for Groot. If you were doing that tool holder thing, it would just be build plate. All the default settings are good except support density. This one is normally 20%, change it to 12% or even 10%. And the support Z distance was the other one I had to change. Instead of the default, which is 0.2, it should be 0.4. 0.2 is just going to be too close, and it'll stick too much. You can save the settings and give it a new profile name if you like for future use. And after printing, you might still find it difficult to remove supports. You can play with these settings until you find things that work for you, especially support density and the Z distance. Okay, so it's a little bit of an advanced topic in slicing, but just, want to introduce that. When you do something like this, you click to save. You might want to then click preview. The preview is pretty cool in Cura. It lets you simulate your print one layer at a time. So instead of having to wait for the printer to do everything and build it up, you can go through and just use a slider and see how it gets built up one layer at a time, which is pretty cool because that also gives you an idea what to expect when your print job is going on. So that's it. And there's my usual plug for, if you you want to contribute something. And then I've got my credits here. So that's it. So I'm going to stop the sharing here. And any other questions before we end? So there's one other thing that I wanted to mention. All right. I'm going to stop recording there.